You're welcome.
This is, yeah, because I joined a little bit early. I paused it. Okay, now it's recording, right?
Yeah.
Okay, thank you so much. Please help me to watch. Yeah, help me every time if I forget to record this, because Tuesday's recording got corrupted. Some internet connection was bad, and the recording was cut in half. And this, this recording is my only hope. Thank you so much.
You're welcome.
Okay, all right. Let's go back a little bit just for the sake of recording. So the goal for this new part is to make a part just similar to this or exactly same to this. And it got constructed by 3 different features. You click one, it's gonna highlight what the feature you made. So it's from a rectangular block and remove material for 2 times. And it gave you this geometry. And now let's go to the new part. Select either one of the plane. If I select the front plane, I go sketch, and I can start with the center rectangle. Well, corner rectangle is up to you, depends on where you place your coordinate. Let's do a center rectangle and start from the origin, and we draw the rectangle, and we click smart dimension to dimension each side to make this square or this rectangle fully defined. So let's just make it a square, 5 by 5. So now we have a fully defined square, and we going to extrude it to a certain length to form that rectangular block. And let's make the length as 6 inches. Well, it seems a little bit short. Let's do 8 inches. So this way, we pretty much just mimic the first feature of the previous model. And now we need to extrude cut to make the step, right? So if this is the side view, we're gonna cut it right here to remove the top right corner, the material of the top right corner, right? So we can start from this plane or start from this plane or either that plane. Like, that doesn't really matter. It's up to you which way you think is easier. Let's do this plane. And we can sketch for another rectangle.
Professor, I had a quick question.
Sure.
What hotkey are you using to like get the rotation view to pop up immediately? Because like I have to search each time I use it.
You mean just drag it like this?
Yeah.
Just your center, the roller of the mouse. You hold it.
Okay, perfect. Thank you.
Yeah. So let's choose this point and make a rectangle so we can perform the extrude cut. And now you can see we're drawing on this plane right now, but it's not perpendicular. So you always use this to make it to normal to, and you can change this hotkey to whatever you want. It's not necessarily must be Control+8. I choose the corner rectangle is because I want to start from a corner. So that way I know the other 2 edges are completely overlapped. And now we have a rectangle. We can totally define it to some value. Seems a little bit small. But we're not necessarily to make it the same as the first model, right? Once we have this geometry, you can see is laid on this surface. And now we can go extrude cut. And remember, extrude cut is to remove material. So every single time you use this feature is you want to make something disappear. So if your extrude cut is based off nothing, and you're not gonna see the effect of extrude cut because you're just cutting air, right? So you go extrude cut, and you can see right here the drop-down list give you multiple options. So blind is you define a depth, and through all is pretty much going through the the furthest surface of the subject. And you, through all both is we have two directions. And in this case, we only have one direction. If this rectangle is constructed in the middle somewhere, you need to use through all both, or define bi-direction of two blinds or something. There's a direction two. If you click it, it can go the other way. But in this case, we just don't need it. So we uncheck that box. And up to next goes to the nearest surface. And up to vertex, up to surface, and up to body, and those are manually select. If I go up to surface, I can select this surface because pretty much this is the only other surface it can go to, right? So it has the same effect of the through all or up to next, and you can use blind since we know the thickness of this block is 5, right? So if I put 5, same thing. So let's do up to next in this case and get rid of the second direction. And here we go, we form a step. And the third feature is also a extrude cut. So similarly, let's select a surface to perform the extrude cut. I can do either this or that, right? Or here. If I go this way, I cannot because we need to leave some material on this side, right? There must be a wall on this side, so we cannot cut from this surface. It has to be either this surface or that surface or this surface. So let's do this one, and I just click extrude cut. Since you don't have any sketch, if you click the feature first, it's gonna automatically navigates you to sketch. So it's pretty much same thing. It just different sequence. And now you can start making sketch, and I will do the corner rectangle one more time until it hits this line. So now pretty much 3 lines are overlapped with the edge of the previous model. Only this line is in the middle, and we can define it to be like 0.5. It kind of looks right. Right, so you see this rectangle is laying on the surface. And now we just need to exit sketch because we already clicked that feature. So now you see this sketch has a little bit of traffic light, means sketch is ongoing. We just need to terminate the sketch, and it's gonna automatically apply the feature we initially selected. And this time we cannot go through all because we need to keep some material at the bottom. And we cut it to 2.5. Seems okay. And click OK. And now we have this very simple model, very similar to this model that we're trying to make, right? So any questions so far? This is just a simple model of how to use extrude and extrude cut of rectangular subject. We're going to do more examples about extrude cut. Any questions? Nothing. Nothing, right? Well, I can't really redo everything in front of the entire class, right? That's the reason we got the recording. Okay, so here we are going to introduce our second model. So from this model, you can see is a rectangular base plate. On top is a triangular model, and on top of the triangular is another triangular. Okay, and same technique. Let's figure it out how this model be made. So first thing, a base plate, and second, on top, the triangular subject, and another triangular subject. So differ from the first model. This time, we're not going to remove any material. We're going to add material. So let's start make a,
Professor, quick question.
go ahead.
How do you decide like if you're gonna build something from the bottom, or like the last model, how you decided like to take stuff away?
So pretty much that's from your experience and also happening in your brainstorm. If you going to make a screw, right, a hex cap screw, what do you think like how it's gonna be made?
I think that'd be pretty hard to cut stuff away from, so I'd probably start from the beginning and build
So
up.
let me ask you this way: if you have a screw, a hex cap screw, are you going to make the hexagon cap first and then make a cylindrical screw body later, and then weld them together?
No, definitely not.
But that would be the easiest way to model it, isn't it?
Yeah, for sure.
Yeah. So it's pretty much from experience and how comfortable you're with your modeling. So pretty much everybody know like the machine screw, it come off like a bar stock or that kind of material, right? It's pretty much the machine is just machine it out from like a square or something, a cube or something. But in modeling, the easiest way is just make the cap first, and so two extrudes, right? One hexagon extrude and another circular extrude, and you have your screw pretty much.
Yeah.
Yeah.
Okay.
Yeah. So pretty much when we see the model like this one, there's another way to make it. Like I can make a base plate first, and then the side wall, and then another side wall, which is not removing material, which is adding material. So there's always more than one way to make a model. It just depends on your ability.
Sounds good. Thank you.
No problem. So let's make this one. And this time, since we're building a base plate first, so let's go with the bottom plane, the top plane, and start with still a center rectangle. And let's dimension it 5 by 5. And we extrude it to 1 inch. And therefore we have a 5 by 5 by 1 base plate. And let's build the triangular shape on top of it. And we know the triangular shape from this view, from this model, is having sharing the plane of this side of the plate and also this side of plate. So we can treat this side as the back and start making a triangular shape, triangular geometry right here, and extrude it to a certain distance that is not going too much to this edge or even going over this edge. So on this plane, we can start making sketch. Since we're making a triangle, and I'm gonna just do line and still make normal to. So select that point and the system will tell you if it's vertical. And remember, always close your geometry since extrude or extrude cut or revolve, all the features are pretty much only work for the closed region. You can't have an open region and apply the feature. And now I click extrude. It tells me where I want to extrude this triangle to. And you can see, apparently we're at the wrong direction. There is a flip direction right here. So in direction 1 or direction 2, they all have the flip direction. And you just need to play with that flip direction till it goes to the right direction you want. And we can extrude it to 4. Just leave 1 inch of clearance. And there we go, we have it. And then the next feature is another triangular piece on top. And it's pretty much right at the center. The way to make sure is we go evaluate and there's a measure. So this is just a measuring tool. You click on 2 surfaces that give you a distance, either center to center or edge to edge. It depends how I set it up from here. So from that surface to the surface is 1 inch. From here to here is also 1 inch. Therefore, we know this little piece is right in the center of the triangular piece we just built. And let's exit out the measuring. And now, if we are going to make a sketch of that triangular piece, where should we start? Since it's in the center, are we able to start from this edge or this edge? So sorry, not the edge, the surface. Which surface should we choose as our reference surface? Any vote? The 1 or 2? Anybody? Well, in this case, I want to go a different route. So it's neither 1 or 2. We are going to make a new plane right in the center. And you can, if you have this little toolbar, you can make a plane right here. If not, you can search a plane and it tells you like either a real plane, construction plane. I mean, this is the real plane in 3D Sketch and all the other stuff. So let's choose a plane and where I want this plane to go. Well, I want this plane to go to the center of this triangular. And I know the thickness of the triangular, the extrude is 4 inches. So pretty much 2 inch from either side. So no matter which side I choose, I just need to offset it 2 inches. And also this direction is going to the left, which is not what I wanted. I flip direction. Right, so this plane is right in the center of this triangular piece. Okay, now we have a plane. And what we're gonna use this plane for is to sketch that little triangle. Therefore, we select this plane to highlight it and go sketch and start sketching. And the same deal, we go normal too and start drawing lines. And I know the little small triangle start from this edge. So I'm gonna start from this point. And then when you see the little yellow symbol pops up, that means it's vertical. And all I need to do is drag it to this edge while is horizontal. And then another way to close this is use convert entity. Since this is an edge line, right? This is the surface of this slope. We can convert that line. We can convert the surface of the slope into a line by using convert entity. So pretty much making a projection. Let's see the edge one in this entity to convert, and I click OK. This become a fully defined solid line. And now to do it, just trim down the extra, which is trim entities. And the first option, power trim, and just get rid of the extra. And I have an enclosed triangle. This line stays blue because I didn't dimension anything, so it's underdefined, but that's okay. And now we need to exit sketch. And you can see this little nice triangle is laying on the plane that we just created, which is right in the center of this triangular piece. And now we use extrude. And you can see it only starts from the center to the left, right? And we're missing the right-hand side piece. And here is where the direction 2 kicks in. And since this piece is smaller than the overall dimension, the only option we can use is blind. And we're gonna make this 1 inch and 1 inch on the other direction. And from the preview, you see we successfully made a triangular piece right on this previous triangular piece. And if you don't want to see that plane, you can just get rid of it from the view. You know, this is this eye symbol, and going there, you can either hide or show different stuff. You want that plane to pop up, you click that, otherwise you unclick it. So you can view your model more like without any interference. Okay, any question about adding material by using extrude? No, so I assume it's all good. You guys can totally do this in a matter of like 15 minutes. What's add? Addition of the extrude. What does that mean? Or the last step. So let's suppress it, like nothing happened. We only have these feature 1, feature 2, and the little plane that we just created. So from this plane, we go sketch. And now we need to, let's get normal 2. I need to start making lines. to have a triangle, right? The triangle in the plane that we just made. And we go extrude. Since the plane is right in the middle, so you're gonna extrude to both sides, right? So direction 2 and direction 1 both need to be activated. And we choose blind because we need them to go certain thickness. And we define the thickness as 1 inch at the 1 inch on the left side and 1 inch on the right side. So total 2 inches of thickness. And here we go. Okay, any more questions about the first one and also the second one? All right, let's bring in another model. So by looking at this model, same deal. It just seems a more complicated form, but from here you can see it's also done just by 3 features. And the first feature apparently is the creation of the main body, and second is to trim down certain edges and certain corners, and the third is the same thing, just in another direction. So let's drag up this blue bar. So very similar to the first model we worked on, a rectangular piece. And we trim it from the right view. So remove top left corner and bottom right corner and create a slope. And the third one is from the front view. So make this cut and that cut. And let's make this purely by extrude and extrude cut. Okay, let's start with the right plane. Okay, we're already done front and top, and this time we're gonna do it at right. And same routine, a center rectangle. By defining it, let's do 5 by 5, or even do 5.5. So it's not a square anymore. And extrude this into, like, I'll do 9, make it a little bit longer. Okay, we have this. And we know from the first step is from the smaller side, we start trimming the corners and make a slope. And we can even make a normal to first and then start to sketch. And corner rectangle. And another corner rectangle. And let's do a line. Okay, now you can see we have 3 independent geometries. And we're going to extrude cut it all at once. This is totally okay, and I encourage you guys to do so you can save more features. So next time when you open up your model, since you have less features, it'll take less time. So to have multiple geometry being cut or at the same time to be included in one feature, which is a better practice. So extrude cut. And you can see it automatically select the preview since we just made these three geometries, right? However, at the bottom, select the contours. You still need to manually select them just to make sure it doesn't cut anything you don't want to cut, okay? Otherwise, if you didn't select all those contours, for example, like the computer think, okay, this is something you want to cut, and it's gonna ask you the body to keep or something. You see, they cut the thing that you want to keep, and which is not good. You have to go back and redo it. So make sure you select the contours that you want to cut and click OK. And you can see we successfully made the first shape. Right. And next step is to make another slope from a different direction and also cut the top left corner. So from this side, right? That side, this side, doesn't matter. All right. All right. Since we're cutting, okay, let's do this side. Since we're cutting perpendicular to the plane that we created this model, which is the front plane, right? We need to make the perpendicular cut. Therefore, either we draw on this plane or we can draw on any plane that is parallel to that plane. So a question for you, I'm going to sketch and I select this plane. Am I doing it right?
No, it's not parallel. Or, yeah. Or perpendicular.
Right. Thank you. Yeah, because if you draw any sketch on this plane and you cut it, they're gonna go 90 degrees perpendicular to this plane. So you're gonna cut it right across the model, kind of like a slash, but we need to select either this plane or the front plane. And let's do this plane. Let's start sketching. Same deal. And we know is horizontal. That little yellow symbol. Okay, I didn't close either one of those because I'm going to convert entity of these that edge and also this edge. So edge 1 and edge 2, I click yes. So they become the line. Oh, I forgot the other side. And also we need to trim down the extra. And now we have two enclosed area. One triangle on the right side and one like echelon form on the top left corner. And we extrude cut it. So from the preview, you can see the sketch, even though the sketch is not touching any of the model and is on the same plane of the surface we selected, but it's fine since we're removing material. So any material along the way will be removed. Same thing happens to adding material. So you don't have to make contact of your model when adding material because it will just, have the material right there. But however, you do need to make sure there is any material along the way. Like if I make these two geometries way higher, it's not touching the model completely during the extrude cut, you're not cutting anything, you're just cutting air. So from here, let's demonstrate it a little bit about the through all and up to next. So let's do through all. You can see these two contours, these two cut regions stop right at the furthest surface. And let's do up to next. It only go up to the next surface of the geometry. So in this case, up to next is really clean because it's not cutting anything extra. And through all, they do making like a lot of extra cut, but they're having the same effect. So in this case, doesn't matter. And here we go. We have the model. Any question before we move on? Okay. So far so good, right? It's easy stuff. Give me some feedbacks. How do you think like is at least it looks easy, right? Oh yeah, totally. With practice, it should be easy. Okay, let's bring the next. Okay, this one is more like a couch, like a throne. And this time we're going to remove material. Same thing with 3 different features. And it worked off a rectangular block, same story, and make a cavity, like a V-shaped cavity. And the third one is cut from the side to make a sort of armrest. And let's do this. So first thing, let's make a square and extrude it to a rectangle. Let's make it a little bit deeper. 5x6. And extrude it by another 6. So our, wait, 6 is too small. Let's do 7.5. Yep, that seems okay. So the dimension is 5x6 by 7, 5x6 by 7.5. And now let's make the cavity of the V shape. Just eyeballing. I'm not measuring anything. The legit way is actually go back to the previous model and either go from the measure tool to see like how tall it is like 4 inches. Apparently mine is not 4 inches. Or you can go into the geometry by double clicking it, and it will tell you the dimension of the geometry they made. So this is a legit way to do it, but since I'm just demonstrating how to make the model by using extrude cut, so I just eyeball all the dimensions. That's why like what I just made is not necessarily identical as the previous model. Okay, so to make the cavity, should I dig it up from the top or I sketch from the side? Tell me, people, top or side? Okay, thank you guys. Yes, from the side, since we're not making a simple geometry is a V shape. If I dig from the top, I'm not able to get it. So I have to work it out from the side. And let's start sketching. And if you're really familiar with your model, you don't have to go normal to. And this time, since we're making a V, so I'll make a center line. And the center from the bottom edge to the center of the top edge. So I have this center line and I'll just draw the V and close it. And now I have one side of the V and the center line. And the next step I'm going to do is to mirror it so that it will the entire V will be constrained by the relationship to be symmetrical. No. I have line 5, 4, and 6 selected and mirror about, which is my center line. And it gave me a preview. Looks pretty good. I'll say, okay. So let me remind you one more time, the beauty of the mirror feature. So is it will keep the geometry completely symmetrical. So when you're gonna move the left side, the right side change simultaneously. It is not like when you draw some arbitrary lines, like from here to there and close it. And when you move this point, the right side would, would be messed up. So this is why I use mirror. And when you're going to build something symmetrical, I strongly recommend you to use mirror because all those regulations. And click OK, and I'm ready to cut it. Since we're not cut all the way through, we only have the blind option. And let's make 4 inches. And voila, we have the cavity here. And the final step, which is easy, is to make a little bit armrest. I choose this plane. And I will go a corner rectangle. So starting from here, my corner, my rectangle perfectly laying on the surface, and just need to cut again. And this time we can use through all since it is going across the entire model. So if you want to mirror, so there is a mirror feature and there's a mirror sketch. So don't get confused. When you're trying to mirror a sketch, use a mirror sketch. When trying to mirror a feature, use the mirror the feature. So the last time I used is the sketch. So if I have a center line, it's not necessarily has to be a center line, but just the center line is more handy to me. So every time I mirror, I would like to construct a center line. And if I have anything on the one side of the center line, I just need to select them all and click mirror entity. And you can see the entities to mirror already been selected in this box. And you just need to set the mirroring axis to be your center line that you just created, or any other reference you prefer. And it's gonna mirror you on identical geometry from your sketch. Any more questions? And also, when you ask questions, just go public, like to everyone, just in case somebody have the similar question, so they don't have to, waste time and retype it and ask again, just to make it visible to everybody, not just like private to me. Okay. Any questions before I move on? All right. All right, last model. The last step. You mean to make the sort of armrest thing right here? All right. So we start from this surface and start sketching by using corner rectangle, since we're going to start from this corner, right? So corner rectangle is, I'll say, the best option to me. And after I make this rectangle, you can define it to whatever you want and apply extrude cut. And from the preview, it cut this far, but we are going to make it go across the entire model, right? That's why we select through all and click check. And here we go. No problem. And this is our last model we're gonna practice for the day. Just keep trying. Sometime it will take multiple attempts. So after this class, after I post recording, just watch over it again. Do not make any run click. Click what I exactly clicked, and you should be making it. All right, this is gonna be the last model before we jump into assemblies. So if you have any question, make sure you ask during whenever I make during the process of me making this model. Okay. So this model, even though it look more complicated, but however, it only has 2 features. Unlike the all previous model, at least they all have 3, right? So the first feature to make the main body, and second feature to make the cut, to shape it into this shape. So the first step is to make this body, even though it is not in a regular they're not like regular geometry. Sorry about my wording, I don't know how to describe it. It is no longer a rectangular cube, right? This time we have something with the neck and also with the sloped back. However, to me, it seems like a rectangle right here, another rectangle right here, and one cut right there. Or you can draw line by line, vertical, horizontal, vertical, horizontal, vertical, and 45-degree up and horizontal. It's up to you. So let's make the first step first. So if I'm doing this sketch, I will start with a rectangle, but not necessarily same thing for you, because I just mentioned it. You can start with lines, right? So I made this rectangle from the center, and I'm going to make another rectangle, start from this corner to make the neck. And I'm gonna use the line to perform the cut. So now maybe you can visualize this. This plus that is the geometry that we're going to construct. And we do have a few extra lines, and we use the trim entity. First option, power trim, just to trim down these lines. And there we go. We have the geometry and we're ready to extrude. And let's go extrude. And the thickness 6 or 5. Okay, so we have this piece right here, and let's take a look. Well, not necessarily the same. The neck is shorter, but you know, we can always adjust it, right? And the slope is more. So every time you want to edit this extrusion, go back to the sketch and just click on it. Just click it once, and right there, there's add a sketch. And once you go in there, you go back to the sketch mode. And from here, you can adjust. Since I didn't define any edges, that's why I can drag it. But if you dimension it to certain value, okay, what's left? This. Yep, this is a horrible example of defining a geometry. I supposed to define it when I first make the two rectangles, and then after the cut. This is why right now this geometry is still underdefined. It will show right here on your bottom right corner, says underdefined. And at this moment, I don't know where. Exactly. Sorry, speak up.
I was just gonna say you were missing that one that you just defined.
Yeah, I feel like I fully defined the model, but it still gave me the underdefined. So if I really want to do this right, I'll just cancel it and resketch and define at the beginning. But at this point, I don't want to waste time on this anymore. I'm going to do the model. But anyway, if your sketch is blue, is totally underdefined, so you can drag it to adjust it to, the certain dimension you want it. But once you define it, then it will turn into black, which is fully defined. Then you cannot drag it anymore. You can only play with the magnitude. All right. So this is the model, which is pretty similar to the step 1 of this one. And let's apply step 2. So the step 2 is some material material reduction from the front view. And you can see one slope right here, one slope right here, and a circular notch in the center. And this is a symmetrical. And we're gonna do, and same deal as the 2 models before, we're gonna start from this surface because we're going perpendicular to the front view, right? So either work on the front view or work on any surface is parallel to. And we're gonna sketch. This time, since we need to really reference it well from edge to edge, we normally do, and start drawing lines. Actually, let's start drawing center lines first. Since we're gonna make the left triangle symmetrical to the right. So I made this triangle and select it. Same deal, mirrored it with respect to the center line. And we have another triangle here. So we have 2 triangles floating with the same plane of this surface. And now we are going to make the circular notch, which is that circular profile. From here, we know the circular notch is definitely not the semicircle. So we know like the origin is somewhere probably right there. We're supposed to measure the radius or diameter of this notch and then do the calculation. But in this case, I'm just gonna pass it. I'll start draw a circle, and you can see the dashed line is to navigating you where you're gonna land your origin, and I know it's somewhere up there. So I'll just pick an arbitrary point and then make it to the point on the triangles, since the 2 are symmetrical and my origin of the circle is from the center line. So they should be touching on both sides. And after the circle, pretty much we're done. We're ready to cut it because the contour first, second, and third are all enclosed. And we can make this circle have a extra line to right here and remove the all the other extra of the circles. But in this case, we're just removing more unnecessary material, and that's acceptable. And let's extrude cut it. And from the contour, we select this, that, and that. Total 3, right? 2 triangular piece and 1 circular piece. And nope, it didn't cut through. Something we skipped. And let's revisit this feature. Yeah, so the preview only gives a 5 inches and in direction 1 and also blind. No, we are going to through all. And now the cut extended to the end of this neck right here. And here we go. So one extrude to make up the material and another extrude cut to trim the model to the desired shape. So this one is more slim and ours is a little bit low profile. Any questions? Anybody? No question at all? So I'm going to move on to some assemblies. All right. Okay. I just opened up assembly. It's something pretty random. I made 2 clamps with 1 pipe, and those 2 clamps are bolted together with 4 hex cap screws and 4 hex nuts. And these 2 clamps are identical. Just the top piece and the bottom piece. And everybody can see this all right, right? Okay, great. This is something we are going to do next week. I bring this up to give you guys a little bit preview, so you know what a simple assembly is looking at like. And we are going to make those from parts next week, and then later on make them together to form the assembly. But I have a couple of questions I want to ask you guys this week. So if I ask you how many parts this assembly has, what would be your answer? Okay, I see 2 sets of answers, one 11 and one is 4. So the reason I'm asking is, you know, we are making model or making parts drawings to support construction, right? And anything with your assembly, it will be summarized in a bill of material. And I asked how many parts in this assembly, it will be the total count of the part number in your bill of material. And let's count it together. So start with the fasteners. Those are the small ones we always missing. A bolt at 4 different spot, but the same type of bolting and same type of nuts, right? So 4 bolts and 4 nuts that count as 8. And after that, we have 2 clamps, and each one are count 1, and that's 8 plus 1 plus 1, that's 10, and you have a center pipe, that's 11. Right? So on your bill of material, it will say total parts needed is 11. The purchasing would be buying total 11 stuff, and then we can construct that part into this assembly. Okay, so total parts are 11. And second question is, how many components do you think this assembly has? So similar question, but I changed my term from parts to component. Now, how many components it has? Okay, easy question, right? I see everybody got the right answer. 4. That's true, because in this assembly, we use repeating parts. Like the bolts, they're the same spec, and the nuts, they're same too, and the clamp, they're same too. And the only unique thing in this part is the pipe. So we have totally 4 parts. So most likely we just need to contact 4 vendors or 4 suppliers and tell them how many bolts we need, how many nuts we need, how many clamps we need, and we just need 1 pipe. And that's why it's 4. The reason I bring it up is in the assembly, during the time I make the assembly, I'll use components or parts, and I hope you guys will have an early understanding of what I'm referring. All right. Any question about today's lecture? If not, you're totally free to go. This is all I want to cover today. And do make some practice. Follow LinkedIn, follow the LinkedIn Learning, or follow the recording video. Yep, just practice for 2 hours maybe, or longer if you want. And you're supposed, yeah, then you're good. Yeah, you guys can stay. That'll help. Thank you guys. Thank you for attending, and have a good week.
Thank you, Professor. Have a good weekend.
Thank you.
Thank you, Professor.
Mhm.
Hey, Professor, I stayed after last week and
Mhm.
asked you about some computer issues, and you were asking for the specs of my computer.
Mhm.
And I couldn't find it, but I found them now, and you said
Yeah,
you would be able to tell.
right. Did you see me reply to your email?
Oh, I did not. Oh, there you go. Okay. Yeah.
Yeah, because sometimes CAD software do have certain requirement about GPUs, and if you're using a laptop that even though have a good processor and good RAM, but GPU is come from a motherboard, is definitely not going to support it. You didn't list your GPU spec, so I don't know.
Okay.
Yeah, so either you can try to find out a GPU spec, but most likely if your computer cannot successfully support the SolidWorks, then either you use the virtual lab or you use the on-campus lab. So, those are your options.
Okay, sounds good. Thank you.
Yep, no problem. Well, have you seen the announcement on Canvas? Hello? Yeah, so pretty much I post all the resources I have. This is where I download my SolidWorks, the same as the others. And I say right here, download SolidWorks 2020. And SolidWorks 2020 is the only thing you need. This one. So what's your problem? And to answer your question, Angelo, I understand you get lost, and your job is to watch the video and practice on your own. No matter how many times I redo mine or how slow I do mine is not going to help you. You need to practice. Okay, this is just a software, kind of like a video game. The more practice, the more better you got. All right, and we're in a college. I'm teaching a college course to all your freshmen or college students. Okay, you need to absorb this independently. I'm just delivering what I'm supposed to deliver, not babysitting. Okay. Okay. Wait till the last, Ben. Anybody else? Do you guys have any questions or any issues? Okay. So Ben, when you download it, did you already got to the step that you need to input your serial number? Okay, so you input the serial number, then it already been downloaded and installed. That's the last step to activate it. So you should have SolidWorks, and it never pops up. Have you ever tried search your computer? It might be just in a different folder or something. Just search SolidWorks, and not every time you download something, it's gonna show it up on your desktop. Okay, if that is the case, I guess you can either use the virtual lab or the on-campus lab, because I'm not a computer guy, and also I'm not here to solve computer issues. I'm just to teach the technique to use the SolidWorks software. So I already told you guys during the first meeting, you can go on CPP to submit a IT help desk ticket, and the IT service will reach you out. The help request form. Yeah, right. This is sometimes it happens to some individual, really unfortunate. I hope you understand, because this is a fully online class, and we do expect everybody to have a capable computer before they sign up.